A lot of people ask me what is the best way of learning programming languages, but also people ask me what is the best way of learning programming logic. Let's be honest with one another. As front-end developers, programming logic is usually one of our weakest aspects because we start learning HTML, CSS, and only then JavaScript, which is a very simple programming language to learn. So what can we do? We practice our programming logic, and it may not be easy. It can be boring. So one of the cool ways of training for that is programming games. Taking simple games like tic-tac-toe, checkers, and program the logic of it. Make sure that you understand how to translate rules from a real-world game into an application that we have. And this is what we're going to do in this series of videos. I'm going to go with you from zero how to create a chess game application with all the rules that chess has and bring it to life in a simple application, but very functional. The idea here is not to focus on the interface of it and all the functionalities an application can have, but on the logic of a chess application. So if you're ready to dive into it, let's get started. Let's get to it then. I already created here a GitHub repository, which I called React Chess. I'm going to put this project into here, of course, as any project should always be. Going to start with Vite. Here on the getting start, just scroll down a bit, I'm finding npm create Vite latest. I have my folder, Frontend Road, just going to create the new project, which I'll call React Chess. Select here React, TypeScript, there you have it. Now I just enter here React Chess, already run npm install. Wait a bit, there's not many dependencies, at least not in the beginning of a project. Okay, almost there, done, perfect. I'm going to clear this up. And now that our first install is done, I'm already going to connect with the GitHub repository. So we start a new Git repository here, so git init, add everything. I'm going to say commit, first commit, and now going to use this one, git branch m. And with that, I can finish this. Let's connect to our repository. And finally, dash. Don't forget the -u for the upstream, as this is the first time we're creating this branch. I'm going to clear this up, refresh, and see that it works. Yes, our project is here on GitHub. That's fine. One less configuration to be done. Closing our terminal. I'm going to open our project per se, which is here. Give you a bit of zoom so you can see what's going on my screen. And the next thing I want to copy from another project I have, the configuration for Prettier. I always copy paste from one project to another. I don't think it's useful to remember what this does. I like this configuration. I'm just using it. In the package.json though, I want to take a look here. Version with 000, I'm going to say at least 001 to keep it not completely zero. And I'm going to install a couple of stuff here. For example, Prettier, lint, and this kind of stuff. So in our console here, npm install --save -dev for dev dependencies, I'm going to put Prettier, what I need as of now. And I want to install as well Tailwind. Let me get it here, Tailwind CSS, get started, and see here already how to use Tailwind CLI or framework guides. Because on framework guides, you will find here Vite. And now here we'll see how we can use Tailwind. Just copy paste everything. It's also, as you can see, dev dependencies with the dash --d. And now going to start Tailwind to create the base configuration. So that's what this command does. Tailwind CSS init will create the configuration, as you see here, Tailwind config post CSS config, which you can already see here in the root of our project. And inside this config, we're going to add this content. Open here, replace the content by the new content index HTML, fair enough, and the source for everything that is JS, TS, JSX, TCX. Finally, in our index CSS, we're going to add this configuration. And why not? We're going to clear up all that we have here. So, like so. npm run dev should be working, that's fine. Before we run the project, I also want to clean up this app CSS in our own file itself. I'm just going to say here, React chess for now. Basically, to have a clean project. Some people like to have already a base project like this on a GitHub repository that you just clone and you have a base where to work from, which is also a nice idea. I like to do every time I start a new big project, I like to do it from the beginning. It just keeps things always updated in case any dependency now needs to be changed or there's a new way of doing something, new technology I want to play with. I just go and create a project when I need. You say it takes less than 5 minutes, clean up everything that we need to remove all of this, and also in our index HTML, remove this here, the 5 icon. And I'm going to say React chess. I close all the files, and what I want us to do now is to start thinking about the chess game. How can we convert a chess game into an application? Before we start creating any components, any code, or bringing assets, installing new stuff, we need to understand what we're doing. And with that, we can plan accordingly how all the components will integrate with one another, how they will behave, what exactly do I need? Do I need some new functionalities? Do I need to import anything? So stop for a bit and think, how would you tackle such a problem? How would be the model? How would you abstract this into an application? If you want to use pen and paper, please go ahead. If you want to draw, do it. If you want just to write in the README file here, everything that you're thinking, please go ahead, or writing anywhere in Notion. You got it. Just do whatever you want, but think about how we want to implement a chess game in our application, how we want to convert the chess rules into our application and make this playable. What are the requirements of our application? After we've done that, we can start creating a couple of stuff. I'm going to say here the components folder and another folder, which we'll call the models. Inside these models, I'm recreating what I think I will need. So I'm pretty sure I will need a piece. We'll say piece model.ts. I'm pretty sure I will need maybe a board model, also a possibility. This board has what? Has squares. So potentially I'll also need a square model or board square model. But here for me, it's pretty clear that the square is from the board. It's an application about chess. Pretty sure what a square means. And now just like these first three, okay, have a board which has squares and each of these squares has pieces. Okay, but don't we also need players? Player model. Yes. Maybe a player has a name, has an ID, or anything, right? And thinking about the logic of the game itself, not just the structure. Don't I need, for example, a move model? So what is a move? Maybe a move is a piece being selected and a final destination. That could be our definition of move. I don't know exactly how it will be, but I'm pretty sure I will need something to represent what a move is. And as simple as it can be, we will also need a game model. So a game is a set of moves that will be played in a certain sequence. Okay, it's basically that. And then maybe we'll have a winner, a loser, or a draw, have a result for this game. We don't know exactly what everything we'll have here, but we know that we're going to deal with at least these models. Maybe you have some others. These are the ones that I can think right out of my mind. Now that we have these models created, it's time for us to implement them, or at least add a bit of information of what they are about, because just their names and empty files don't help us much, right? I'm going to start with the piece model because I think it's the easiest. So I'm going to export the full class piece model. Inside this piece model, I'll have a type. What is the type of piece we use? What is the type of this piece? This type needs to be, as we're using TypeScript, of piece type that we are going to create just here. This Zenun, we can export it. So export this Zenun, this type, which you have pawn, being pawn. You can say pawn, it's p, whatever you prefer. You can even remove if you don't want to, but I like to have them, the values being matching the values of the num itself. And here I think it's also quite fitting. So I'm going to replicate this for our types of pieces. Knight, bishop, rook, queen, and finally the king. Okay, so this is the piece type now for our private type. This type will say that it's a read-only type because we don't want it to update after the piece is created. This will be the same at all times. But when the pawn promotes, we delete the pawn and create a new one, okay? We don't want to update the type of the piece during the game. Let's create a constructor. Inside this constructor, we receive, of course, a type of type piece model, piece type. And now we're just going to say this dot type equals. Simple as that. First, information that we have about the piece model. Another information that may be interesting to have in our pieces, it's their color. So we have here player model, and each player plays as one color. So we could add the color here in our player model. It's what I'm going to do. Export enum player color being white, white, and black, black. Have these two options. And now in our piece model, and here we're going to import this. So import the player color from our player model and use here again the color type player color and receiving this, of course, this dot color equals color. And this is the definition of our piece, at least what I have in mind right now. Every piece has a type and a color. Don't a piece has a position and stuff? You could say that the piece has the position, but in my current thinking process, it makes more sense for the position to contain a piece than to a piece to say in which position it is right now. Don't know if that makes sense to you, but it's the approach I'm following right now. Maybe we need to change it later if I see that this is not the correct way. But what I have in my mind right now is that a square, there is a position, has a piece. So export default class square model, which can have a piece, private piece. And here it's going to be of type piece model, constructor. Not necessarily we need to have a piece in the constructor because we can say, okay, we need a piece model, but most of the squares will not have any pieces on it. So I'm going to leave the constructor empty for now and create another function here, which will be the set piece. And this one, indeed, it will receive a piece of type piece model and sets piece into that. Now, each square must also have a row, which will be a number, and a column, which will also be a number, as you can imagine. These row and columns, in general, it's not just the numbers, like the column we have from A to H, but it's much easier to work on programming, as you may imagine, with numbers from 1 to 8 than from letters, right? And also interesting to keep the numbers, although the export is always 8 by 8, we could allow in our application to have different types of boards. If we want to have a board 10 by 12 or 10 by 8 or whatever. Okay, we know that the definition of 8 by 8 is the normal chess game, the classic chess, but we could allow for certain different modes which do exist. Here we have then the row and the column being numbered. And these one, they need to be specified. So I'm going to have here a row number and column number as well. Setting them this dot row equals row, this dot column equals column. Is being set there, okay. And the row and the column, after they are set, we can never change it. That's our square model. With the square done, at least what it seems to be for now, we have our board model. Boards is just a lot of squares, right? It's just a set of squares. Let's create here export default class board model. And here I'm going to create them private the square model. So I'm going to say here squares. Now square model. But it's not just one, it's several of them. And here, and this is quite important, a lot of people will do this. A board is an array of squares. Because you have columns, you have rows, it's a matrix, right? It's the most obvious approach to deal with a board. You create an array of rows or columns, however you prefer, and then inside this, each column is an array of squares. However, a chess game is just an array of square model. 64 squares inside the same array. This approach is easier to work with, especially when we are calculating the movements or anything else. When we need to calculate, let's give it here a bishop, which goes in the diagonals. You will need to traverse the two levels of arrays to find the correct positions and see if there are pieces in there and so on. Like so, when we have an array of square models, we just go through all this array, searching the possible outcomes. Okay, it will be easier. And actually, we're going to see later on that most likely this array will even become a map or a set or another data structure, which will make much more sense and allows us to find squares much easier. But for now, array suffices. Don't get me wrong, if you want to do an array of arrays, it's totally plausible. It's just not the easiest solution to work with, and most likely not the fastest neither. Now, we create our constructor, and this constructor receives nothing, but it will initialize all these squares. These squares will be an array of 64 square models. So instead of creating here one by one, we're going to use a loop, of course. Let's go here. So 4, which already added here. Let I equals 8 equals 0, sorry. I is smaller than 8, I plus plus. And I like to do with W, not with J, okay? With W. Smaller than 8 plus plus. That's our board, basically. We're going to make from 8 until 64. And now here in this dot squares, we're going to push a new square model, sending the row and the column. Simple like that. Like this, we start our board. We didn't start yet with the pieces, sure, but we're going to do that soon. As of now, we just want to add these squares into our board. And I'm going to check this out. Going for our app, TCX. Here we'll return just React chess. I'm going to create just a normal const, not even a state as of now. Const here board equals new board model. Simple like that. And then I'm going to log this board. Start our application again. Oops, not the fastest it seemed today. Okay, then coming back to our Chrome, open this a bit, see here, our console, see the board model. This board model with squares going from row 0, 0 until here 63, perfect length 64, so row 7, column 7. That's exactly what we need, and you see that the piece here is undefined because, as we said, we didn't put any pieces. What we can do now is to have all of these squares being drawn already in our page. So let's go ahead and do that. I'm going to create here a component, which will be the board, inside a folder called board. And that's why I write model after all the models, because I like to separate them between components. They're just the name, and then they don't have any conflicts with the name of the board model, for example. And now I'm going to first create a const here, board, the function. Now export default board. This board will have an interface. Props receiving, as you may imagine, a board, that board model. Writing it here already. This is structuring. Why not? From props. And we're going to return, as of now, just written here, board. And in our app.tcx, React chess, this in a h1. Also for semantics, okay? Don't forget that should always have one h1 before having h2, h3. Don't use it just to define size, define it, use this define semantics. And now inside of here, we're going to add our board, which receives, of course, the prop board. We're back. Okay, see React chess and the board. Let me remove this log from here and transform this board now into a state. So I'm going to say here board. I'm not going to receive the set board because I will not need it, at least all of now. It's just to use the state. And with first value, it will be a new board model. Now it's a bit better. So it's using the state, using the React hooks, the use state, and this will be updated in the board whenever this is updated here as well. Although, as of now, we are not updating anything. And in the board component, we can start drawing it. But to draw a board, what do we need? We need squares. So let's create inside the board folder itself. I'm going to say here square.tcx. I'm going to copy paste this directly. And I square will receive, as you can imagine, a square of type square model. Let's just add this import, change here, and say square. And for now, I'm just going to this square dot. I forgot to create. Let me get here the square. I forgot to create the get the values square model. Get row, get column. I could make this not private as well. It would work. But then like this, I could also update the piece, just saying square model dot piece equals something instead of using the set piece. Not sure I'm that much of a fan, but for now, yeah, for now I'll leave it like so. And we'll see. So square dot row slash here square dot column. That's our squares. The board, what we have here, the board model. Do we let this private? Probably not. Probably yes. That's a good question. It's always to understand if do we want to keep all this information private, if it's read only, if it's not. It's stuff that we need to understand given your domain. Here, I'm not going to let it private. I'm going just to allow the access directly because you may want to change the squares of the board or at least change the pieces inside the squares. Up to see, up to debate, but as of now, I'm going to keep this available for our board to use. And here in the board, now it would be an H2 because we already have H1, remember semantic. we're going to have a section. Inside this section, we're going to say board.squares.map. Square is of type square model. And here we're going to send then our square component. Not this one, this one. Our square component receiving, of course, this square. And we will also have, added one that's not needed. And this square will need to receive a key, which I will say is square what? Square dot row and square dot column. Add this import. Organize here. There you have it. This is our simple board, which now if we come here, of course, and refresh it to remove the errors while we're doing, we see that the square 0, 0, square 0, 1, square 0, 2, until, of course, our square 7/7, which is the last square of our board. Let's head to Tailwind and search here for grid. Have here grid template rows. So first I want grid itself, so template columns, grid gap, okay. So we need a grid which is of 8 rows, as we already have Tailwind. That will be quite easy for us. This section, give class name, need to be a grid rows 8 and grid columns 8. I suppose it's this one, right? Now let me refresh here, inspect and see what's going on. You see here is the grid. I see that the classes are being applied correctly, but it's not columns 8. Seems I got something wrong. It's cows. Okay, of course. Cows 8. Nice, 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 nice. Now I have here the grid rows 8, grid cows, both of them. It is the display grid, and all of our squares now are one under the other, which is not what we want, but fine. At least we know that Tailwind is working, and our grid rows and grid cows as well. Let's go back to our code then, and have here in our square, instead of creating a fragment, we can just call this a div. And now everything will be in place because our grid is in place. See here square 0, 0, 0, 0, 1, 0, 2, and everything. Let me even remove this text, we don't need it. And see that we have our grid. And this is our board, as simple as it may seem. Now, before we paint these squares with light and dark, if you're used to chess, you probably already realized that this square should be here. And this one should be here. They're swapped. Because when you're looking at the board as white, the first square 0/0, which is A1, is on the bottom left, going all the way up to H8, which would be our 7/7. So before we even start painting them, to not create some confusion, let's fix the order in which they are shown. And to visualize that better, instead of showing the row and the column the way we are seeing now, just 0, 0, 0, 1 and stuff, I'm going to organize them in the correct chess notation, which is using the row with the numbers here and the columns with the letters. For that, you may guess, but I'm going to create a service. So services here, and I'm going to create one, the square service. .ts const to be get square coordinates, and this one will receive a square model. Should be here square. This is a pure function. We want to make this a pure function. Okay, so we're not going to modify anything inside the square model, and square coordinates would always be the same given the same square. And I'm going to return the string. Let's say here string. I'm going to return the square dot column and then the square dot row. But as I said, this is not the correct notation. First, because the rows go from 1 to 8, not from 0 to 7, so we're going to increase this by 1. And the column goes from A to H, not from 0 to 7. So I'm going to say convert column notation, simple like so. And this convert column notation, convert column notation, let me export this one actually, and not the second one. I'm going to receive a column, which be a number, and we return a string. Here we're going to do a simple switch with column, and we'll have case 0 return A. Repeat this several times. 1, 2, 3, 4, 5, 6, 7. That's it. And in the end, just in case, we're going to return an empty string just to always have a specific return. Now here, B, C, D, E, F, G, H. Is missing here my arrow function. Have here our switch, then everything as should be. If this gets square coordinates, we can come here and just put this inside a span, let's say, and go for get coordinates, import, sending the square, this function. Okay, come back here. Now we see with the official chess notation from A1 to H8, but A1 should be here and H8 should be here. So actually the only thing that it's wrong here is that the rows were starting the rows on top, and if you're used to chess, you know that the rows start from the bottom. At least when you are looking as white. When you're looking as black, H8 is here and A1 is here. So what we have here is, if we're looking as white, we should invert the rows. And if we're looking as black, we need to invert the columns. That's what we need to do. And of course, we can do that with CSS. Going back to our code, then let's give this a class name. It'll be here a template literal. We choose say co start, and now the position. This is a Tailwind class. Define the position of this square into the grid, which column it to be used. Of course, this changes, as we said, if you're thinking as white or black, but for now, we're going to keep it just one side and then we invert. Okay, co start. What is the position? The position is the square dot column. Here, +1, because we go from, if we check here, Tailwind, you see that grid column start end, we go from 1, co start 1, until more than 8, of course, but we just need until 8. And then, as the column starts from 0, we just add 1 to make sure that everything is fine. If we come here to our page, though, we see that div class co start 1 doesn't change anything. And even if I add, now here, row start square dot row, and here +1 as well. We're going to see that this is not exactly what we need to do, but just for us to check something. These classes, they are not being applied to the element. They are here, but they're not being applied here. This happens because Tailwind injects all the classes needed all at once when we are building our project. But as we didn't specify the class directly, this is being determined on runtime. Tailwind doesn't know that the co start 1, 2, 3 until 8 is needed in our project. So these classes are not injected in our code. Furthermore, these classes don't have any styles then on it. That's why we have here on the class of the div, but there are no styles on it. We can fix that by coming to Tailwind config and adding a safe list. A safe list is an array of classes, Tailwind, that we're going to use always in our project, even if we're going to use it dynamic, which means that everything that is inside of the safe list will be inserted in our project, even if we don't use it. So let's add this here and make sure that you use this with caution. Do not grow, of course, your CSS unnecessarily. But we have row start 1, and we have all of this until the 8, right? Can do it like this. Let's do this a bit smarter. Let's go. Even before this, I'm going to say const row safe list, row start safe list. It will be an array. And now for let I equals 0, I more than 8, I plus plus. Or even better, 1. And now row start safe list dot push what row start, make this a template literal, I. So we don't need to repeat everything on our run. Creates a bit more of computation here, but as this is done before the build anyway, this doesn't affect the final performance, so no problems with that. And now in our safe list, we're going to say the row start safe list. And we do the same for the column. You could create just one array, you could insert everything directly, whatever you prefer, okay? Not a problem, it's just to avoid creating all of them here directly in the safe list and copy pasting everything. So this is slightly better. Now we also destructure the column start safe list. And with that, I'm refreshing here, you see that row start has here correctly then the style being applied. And I think I just forgot, here's not column, here's co. And I see co is start as well. If the class is working, we can start making in our square.tcx what is exactly we expect of these values to be. Because of now we just said that the 0 is the 1 is the 2, and so on. So they kept exactly the same position as before. What we need to invert is, for example, the square row. We can say 8 minus square row. Now we're going to invert everything regarding the row. So you see that the 8 now is on top and the 1 is on the bottom. If we do the same for the column, we invert the columns. You're gonna see that the H is here. As I mentioned before, if we want to see as white, we'll invert the row. If we want to see as black, we're going to invert the column. But before we do that, I would like to think, and I want you to think with me, does it make sense that the square is positioning itself into the board? Or wouldn't it make more sense that the board positions the squares into it? For me, this second option, it makes much more sense because it's not part of the responsibility of the square knowing where it should be. The square has information about itself, has its coordinates, yes, what is its position in the board, but not to draw itself correctly. The board makes much more sense for me that the board does that than the square. So for that, I'd like to recommend we create a new div here with this class name instead of using this inside the square. And now the square becomes a fragment again with this span, but of course we're going to have more stuff later on. And with this, we have the board taking control over the positioning of the squares, which is exactly what we have here. Okay, perfect, all the same. Let's create some calculation then and say that this square column or square row should be different if we're playing as white or as black. Maybe we can create a props here in the board and say playing as white, being a boolean. You could also say playing as and receiving a white or black, like a player, just like we did here in the player model, receive like a player color there. It's also a possibility, but as chess always has just two options, here I'm going to opt for a simple boolean, but in the end, it doesn't make any difference, okay? Do as you prefer. Playing as white. If we're playing as white, the row start will be 8 minus square row. Otherwise, it will be square dot row plus 1. Let me get here. Props playing as white. And co-start, it will be the opposite. So if we have playing as white, the square dot column plus 1. Otherwise, 8 minus square column. We could even extract this in a function if needed, but I think this looks good enough. And now in the board, which is being used here in the app, we're going to define if we are playing as white or not. For now, yes, let's see, playing as white. A1 to A8, H1 to H. That's perfect. If we set this to false, now we have H8 to A1 because we're playing as black. And I think this is a very good spot to stop our part 1, and I will see you in the next video.